Hello everyone, welcome to the Kubernetes course for beginners. This is going to be an in-depth course, and first we are going to start with understanding the application that we're going to use. Then we are going to go deep inside and understand how to containerize it, and from there we're going to start our Kubernetes tutorial fully. I do want to point out that we'll be using whiteboards in between to understand concepts that are concrete to the development of Kubernetes, right? So please keep that in mind and let's start. So the application that we're going to use is already in GitHub Repository. So this is the application and this is the Kubernetes tutorial. So if we go inside the application, there is a README file on how you can install all the prerequisites that you need. And if you want to skip this video as well, you want to do it on your own, you can just follow all of this, right? And you will be able to start the application, run it, and see how it works, right? So, but for people that really want to follow the course and watch the video, you can just follow me step by step as I do it. So as well, once you finish that, that's of course if you want to do it on your own, you can come to Kubernetes tutorial, and I've actually numbered this tutorial one after the other. This is 00 tutorial, this is pod, this is service, and this is our application that we are going to run inside our Kubernetes cluster, right? So you can find the README. We are going to be using Minikube. Everything that we are going to do is going to be on our local kubectl. We install it locally and all that, right? So make sure our Docker desktop is installed, so you don't actually need any cloud provider services for this course. Everything will be done locally, and our MongoDB community server edition will be installed locally as well. So without any further delay, let's begin the course. So the first thing we are going to do is to install MongoDB community server edition. So just go to google.com and say install MongoDB Windows, and it's going to bring you here. So the reason why I'm doing this, of course, you already know my operating system is Windows. So I'm going to install this. If yours is Linux or Mac, you can see it there. It's install on Linux, install on Mac. Just follow this process. It's very easy. And you can install MongoDB using MSI. And also you can install from zip file. I actually used downloaded my own using MSI, right? I've done that, and once you do this, you can install it and you start it. Let me show you. Make sure when you're installing to ask if you want to install MongoDB Compass as well. So install it, because you'll be using MongoDB Compass to communicate with the local database, right? So this is it right here, and I've connected. For you, it will not be like this, so you may have to come to 1 second, add new connection, and you see MongoDB localhost 27117. Just save and connect. That's all you need. Once you save it and connect, you should be able to see it here. So if I press connect here, and mine is up here, right? So that's the first step, right? And the second thing that we need to do if we go here is we've connected. I'll show you how you connect. Then we need to install npm and Node.js, right? And just go to Google and install Node.js. Once you click this, you can come to download Node.js. I've installed it already. And all you need to do is the version that you want. I'm using this 22.15, right? That's a long-term support. So I prefer that, and mine is Windows. Check your own, if it's Mac, if it's Linux, right? And it comes with npm, right? And those are the two things we need. Scroll down and click this, right? I've already done that and I've already installed it. So if I come to my git bash here and I say node dash dash version, and that's my node version, and to confirm that my npm is installed, I'm going to say npm, and it should list the commands for npm. And that's it about npm. So the next thing that we need to install is right here. Okay, great. So we need to do this npm init-y, which is initializing, and then we are going to install our dependencies. So this way, so because of that, I'll explain the project. So this application is a simple login API, just like the name says, right? It allows you to log in. First, you have to register with your email address and password. And once you do that, it's going to tell you user registered if your information is inside the database. And you log in. Once you log in, it's going to return a JWT token. That means you've successfully logged in. And if you are not able to log in, maybe your username or your email is not right or your password is incorrect, it's going to return an error as well, right? So with that being said, we are using our local MongoDB. So I'm passing it in this Mongoose Connect, right? This is it right here. And if you look at my MongoDB compass, you'll find this here. In yours, when you connect, you won't see it here. But once you connect successfully from application, it will dynamically create this simple login DB. So in case you don't find it here, don't worry about it. You will see right from the start. So great. So then what we need is .env. This is mandatory. I didn't upload that straight to my GitHub. It's in my it should be in my .gitignore file. So JWT secret, it should be like this, your super secret. That's it. That's all you need, right? And this is our auto controller. And if you register user registered, and if there's an error 500, it's going to tell us server error, right? And if you try to log in, wrong email or wrong password, it's going to return invalid credentials, right? So, but if you pass, it's going to return a JWT token, right? So that's how this application works. So I prefer to use Git Bash, and this IDE is VS Code. It's something that is on every machine. So in case you don't have VS Code, just go to Google and download VS Code. And this is for Mac, Linux, and Windows. Just come here. And right there, I've installed mine. Whatever is yours, just pick it. And these are different architectures. Mine is x64. Some people may not be, there are other ones like ARM or something and all that. So just check for yours and install it, right? So let's go back here. And VS Code gives us the opportunity to use different command line terminals on our IDE. So I'm just going to go here and I can choose different ones. So I want to use Git Bash. And if you are wondering how to use Git Bash, once you install Git, right? And if you come here again, I'm going to show you how to install Git Bash if you like it. I just prefer it. Of course, you can use your PowerShell and you can use your terminal on Mac. Just come to Git Bash download, and this is the page. Download, and you can choose whatever OS you want to use, right? Windows, Mac OS, Linux, Unix, the one we want. And once you install it and follow the instruction, you would be able to install Bash successfully. So I'll go back here, and we are going to follow the instruction right here from our application. And what we need to do first is initialize. So we'll come here and see npm npm init-y, right? Great. And the second thing we need to do now is do this. So I'm just going to copy and paste this. And this is installing Express first, which is what our API is using to build its application. And Mongoose is for database. And this is for our JavaScript. And this is for our web token. And this right here is for our application to be able to access the .env file. Right, so let's install this. I'm going to copy and paste this. And it's installing. Great. And after then, we need to save this because we're starting our application on local. Just follow this process. And this is great. Now we can do two things, right? Is either we do npm start, which is ideal for production or Docker, because we are going to containerize the application anyway very soon. Or you can run npm run dev, which is ideal for local. So you can use any of the two, it will work. But I will just stick with npm run dev for now. And I'm going to say npm run dev. Great. All right, and our application is up and it's listening on port 5000. You don't need to change anything in the application, right? And it's connected to MongoDB. So how do we test this, right? If we go now to our local host 5000, you see this, cannot get this. Don't worry, you won't see it here. But we use something called Postman to actually test the application. So to install Postman, all you need to go to Google and download Postman. Download Postman. And here, Windows 64, that's my own. And if yours is Mac, Intel or Apple, or it's Linux, you can always pick whatever you want here and install it on your PC. Great. So I'm just going to, I have Postman installed already, so I'm going to say Postman. Go here. And let's wait for Postman. And Postman is up. I've already tried different things on it, so in case you see. So I'm going to allow this. Great. Allow access. And I'm going to close all of this and start again from scratch, right? So that everybody can be on the same page. I'm going to delete this. And I'm going to type simple login API. And I'm going to delete collection. Now, starting, so what we are going to do right now is I'm going to, now that our Postman is open, I'm going to create collection. And the first thing, I'm going to name our collection. And the name of the application is Simple Login API. Great. And now after then, what we need to do is add a request, right? And our request is going to be a post request. Post request. And we are going to be using where our application is listening. So if you come to this, you'll see the application is listening on this. So we first want to register. You can copy this. It's listening on 5000, right? And come here and come to body, choose raw, JSON, right? And you can come straight here and just copy this JSON. And if you like, you can just change it as you want. And I'm going to do something. I'm just going to change this. I'm going to say training tech@gmail.com. You can use whatever you want. and I'm going to leave the password that way, the same way, and I'm going to press send. And this is first registering. I'm going to press send, and return 201 created, right? And if we check inside our database, I have different ones inside the database. So once you do it for the first time, it will create this simple login DB for you. We're going to go users, and if I come down, this is the new one I just created, trainingtech@gmail.com. And now I'm going to do something. I'm going to say register. So let me change the name of this, rename, I'm going to change it to register, and I'm going to save this. Then I'm going to create another request, add request, and this request now is going to be to login. So let me just come here, and I'm just going to change this to auth login, right? So if we go here, it's right here, login, and go to body, JSON, and it's right here, right? And I'm going to use this same JSON because I have it in my database already. So if we log in successfully, this is going to return a token, a JWT token to us. So let's send. And we have 500 internal error. It's telling us we are unable to log in, and there's an error, cannot destructure property. And that means probably we didn't write it well. So let's check. Localhost auth login 5000, and we're using post, and everything is right. And let's send again. I don't know why it does not know how to handle this. Wait, hold on. Oh, it's text. Sorry, we should change this to JSON. It should be JSON. So don't be like me. Use JSON, please. And if we send that, it should handle it. Right, 200, okay. And it returns a JWT token, means everything is working fine. So that's the first thing. Now we know the application is working. Let's begin to really understand Kubernetes and its benefits first. Then the next thing we are going to do is learn how to containerize our application. Right, so let's do that. So I'm just going to open whiteboard. Great, so let me clear this. Right, and we are going to start just from understanding the benefits of Kubernetes, right? First, to first know the benefit, we have to understand that Kubernetes is a container orchestration tool developed by Google, right? And this is not the time to understand its architecture. We're just going to understand the benefits. As time goes on, we understand the architecture. So let me see benefits. And the first benefit we are going to talk about is velocity. The benefits of Kubernetes are immense, and that's what those benefits are what makes it so spectacular, right? So what is the velocity? What does it contain? So first we have to talk about the immutability concept. And what does this mean? So I'll tell you, if you have a pod, you can actually log into this pod, update the pod, and create a new version of this pod and discard the old version of it so that the new version will be in a desired state that you want. That's the first thing. And the second thing about immutability is that you can actually create a new image that contains your new changes, and your new image is going to be your new artifact, and then you can install it or deploy it as a new version. Those are some of the immutability concepts that is really, really, really good with Kubernetes. Then we are going to look at something else, and it's declarative and imperative configuration. I'll break this down for you. Now, imperative are the commands that we enter into Kubernetes. Sometimes you see people saying kubectl, get pods, kubectl, apply, right? Those are imperative commands, and it tracks how your cluster behaves, but not like the declarative. The declarative has a way that you have to define your state in manifest file. And what happens in this place is that Kubernetes tracks your actual and desired state. Meaning, if you want a pod, if you want an application to have 2 pods, Kubernetes makes sure it's 2 pods. And we'll go deep into details of how this happens, right? So then the velocity, once we look at another example of velocity, we are still in velocity, so is self-healing systems. And what's the self-healing system? Let's say you have an application and you've scaled that application into 2 pods to be able to undo traffic, right? And if, for instance, because we know that pods die and all that, this pod dies, Kubernetes will make sure that it comes back up. It will keep retrying it until it comes back up. So that's the self-healing system. That's the benefit of velocity in Kubernetes. So for us to understand the velocity, I will just summarize that here. And velocity, which is one of the benefits, which consists of 1, immutability concept, declarative and imperative configuration, and what? The self-healing system. So if we look at another benefit of Kubernetes and why it's topping the chart in the industry, we'll talk about scaling. This is, you can scale your software and you can scale your team. For instance, what do we mean by this? So for instance now, if you have an application running in a Kubernetes node, right? If, for instance, now you want there's traffic, and traffic means many users, right? Let's say high traffic. Your Kubernetes will detect this, right, and increase your pod to actually entertain this high traffic. And when it goes down, maybe there's a low traffic, it scales it down automatically, right? That's just the function of scaling in Kubernetes. And of course, we'll go deeper into that as well. Then we have the benefit of decoupling. Since Kubernetes handles microservices, right? You can have team A working on a microservice, team B working on another one, team C working on another one, and they are going to be all in the same node, and they will be differentiated by different namespaces. So the resources of team A will be in a namespace that is different from here and it's different from here. So this one will not interfere with this one, and still those microservices will be able to connect to one another using kube proxy, which we'll also talk about as time goes on, right? So I'll just leave that for now. We still have more benefits like abstracting your infrastructure, right? And what this just means is just Kubernetes knows lots about cloud services, so it can help you to create load balancers, volumes, etc., right? So if you're a developer or DevOps engineer, you don't even have to know how to create these resources in the cloud. Kubernetes will help you once you specify it in the manifest file, it will create it for you. So those are just a few benefits that make Kubernetes to be so useful in the industry. So now the next thing we are going to look at is a very important management tool, container management tool in Kubernetes in the industry, right? That is very important to Kubernetes. I have to let you know that Kubernetes cannot do without a container runtime, right? So, and it's the one we are going to be using is Docker for this course, right? Docker. And this is not a Docker course. There are other courses about Docker, so you have to know about Docker at least a little bit for you to be able to follow this course. So if you don't, please try and watch training courses on YouTube or anywhere else, or read a book about Docker. Then after then you'll be able to continue. So we already have a branch here, which is Docker. If you come here, you will find the configuration of Docker. You find Docker file here. You find README about what we're doing. Install Docker. I'm using Windows, so I'll be installing Docker Desktop. Then after installing it, we create the Docker file. Then we need to change this connection string. So this is MongoDB host Docker. Before I was using localhost. So we're going to change this. And the reason why we're going to change this is when you create a container, it has its own isolated environment and comes with its own IP. So I'll show this. So for instance, this is your PC or VM, right? So when you create a Docker container, let's say this is a container, and the container has all the resources for your application to run. It's going to be in its own isolated environment, and it's going to have its own network, right? and it's going to have its own private IP. So with that, you won't be able, except you port forward, you won't be able to interact with your PC. So it's only all the containers that are inside the same Docker architecture or Docker container runtime that will be able to talk to one another. So if you want them to talk to your PC, you have to port forward to be able to interact. So if we still have this db.js, if we still have this, what will happen is the container is going to look inside its own Docker isolated environment and try to connect to any to a MongoDB that is listening on 2717. So it's not going to be able to find it, and thus the connection will not be possible. So in that instance, what do? We need to create this, and this works only for Docker desktop. We need to say host.docker internal, and it's going to look outside of its container and go to the local to actually connect to this one, right? So it's going to connect to this our simple login DB. That's why we're doing that. So then after that, we're going to build our Docker image, and after building it, we are going to run it and make sure it works. Then the next thing is we are going to, if you don't have Docker Hub account, we are going to sign up on it and then push our image to Docker Hub. So that's just in short. So to be able to do that, let's just go to Visual Studio Code, and I'm going to say Ctrl+C and Ctrl+C, and I'm going to clear this. And what I'm going to do now is I'm going to say git checkout, because it's on my Docker branch. I'm going to say git checkout Docker. And because we ran something, so I'm just going to say git stash, don't worry about that. And I'm going to say git checkout Docker. Great, and we are in the Docker branch, right? And if you look at this, once you switch to Docker branch, automatically you see this right there. So we've already written a Docker file. I'm just going to explain this. And what this is going to do is say from node 18 Alpine, and this is an image that is small. That's what I'm going to use. And I'm going to say create work directory app inside this node 18. Remember how our application is running on Node.js. And then copy package.json into this node Alpine, copy it on the home folder, right? Then run npm install. After running npm install, then copy everything back inside this app directory. Then expose 5000. If you don't expose this 5000, there's no way your application will be able to communicate with outside environment, right? So you have to expose it. It's important. Then we are passing a command which is npm start, right? So it's going to start the application. So with that being said, let's go to Docker desktop. If you want to install Docker, all you need to do is say google.com, because you need Docker to be able to build it, and say download Docker desktop for Windows. And once you go here, see, I'm using desktop for Windows. For this, if you are not using a Docker desktop, in that case, what you need to do for this one is you are going to have to leave the old database connection string. You are going to have to leave it there and use Docker Compose to start this application, right? You have to use Docker Compose to start the application. That's the best way. But if you are using Windows, you can just leave it this way and it's going to work. So with that being said, so just come to Docker desktop and this is for Windows, right? You see for Linux here, you see for Mac here, right? See it here. You're going to be able to download, and I've downloaded and installed it. So because of time, I don't want us to waste time, and so for that, I'm just going to start my Docker desktop. So I'm going to say Docker desktop. And while our Docker desktop is coming up, let us just run through Docker to just understand a little bit about it. And like I said before, Docker is a container runtime, right? It's a container runtime, and ignore this for now. And Docker image is the smallest deployable unit of Docker. So what happens here is Docker has all the processes, including libraries, to run application. It will package it and run it in its own environment. This is very powerful, right? So the process of Docker lifecycle is like this. You have the application, then you build it into an image, then you run it as a container. That's just how it works, right? That's just how it works. And there are different categories of Docker. We have of Docker containers. We have system and we have application. So the one we are using now, Node, is application. You see Python is application. There are other ones like which are getting obsolete now, like VMs, like SSH, cron jobs, and these ones are really not really things that we, but now Node, Python, Django, no, not Django, different, there are different varieties of it, Ubuntu, Debian, and all these things. These are the ones that we use now, and you build your applications inside this image, you bundle them together, right? So that's about that, about Docker. So I tried to start my Docker desktop. It's complaining of, I think it's resources. So let's see. This is a good way to show that this consumes a lot of resources. So let's start our Docker desktop. One. In there. Yeah. Okay, let's wait. And the engine stopped. Let's troubleshoot this. Task manager is basically because I need to stop some applications, I guess. Okay. Failed to start, and not enough memory to start. I know that's why. Memory to start. The engine is starting. Engine is stopping. And I'll close this. Close this. And all right, now Docker is up and it is running. Docker is up and it's running. Good containers. Great. So what we need to do now is we need to containerize our application. And if you come here, what we need to do is build the Docker image. We've gone through the Docker file and how to build it, and it's a very simple Docker file. So this is how we build it. We just say docker build -t TechWithAdeDayo simple login API, and I'm going to go here and I'm just going to build that. So if I say docker build -t, and I'm going to say TechWithAdeDayo and I'm going to say the name is simple login API, and I'm going to say version 1, which is the tag. So for people who have not opened a Docker Hub account, I'm going to show you how to do that. So all you need to do is just come to google.com, just say Docker Hub, sign up. And once you come here, you can sign up. I've already signed up. I have an account, so it's going to take me. Okay, great. So you can sign up personal. But I already have an account, so let me just log in with my account. I'm just going to continue with Google. Nope. Okay, this is sign up, so I'm just going to sign in. Right. I've signed in because it remembers my thing, right? So it's saying welcome back Adedayo, right? If you don't have an account, please, you need an account. It's going to give you, you are going to put your username, and in this my case, this right here, this TechWithAdeDayo is my username, and this simple login API v1 is my repository name. And if you don't want to have an account, it's not by force. This, I already have this image, this one, and version 1 and version 2 on my Docker Hub account, so you can always use mine to follow the course, right? So you don't have, it's not by force, you can do that after later on, right? And just stick with this. So if I go here, I can just say google.com, and I'll say Docker Hub repository. And if I say this, and it should take me to my repo. Yeah, it's taking me to my repo. And already, so this is my username here, TechWithAdeDayo, and this is the repo name. So you can just create your own repo, create a repository, and give it a name, right? Put short description and create, right? So let's go to repositories. This is my own. I already have two versions, right? This is V1, this is V2. We are going to use them both when we get to Kubernetes. But for now, let me show you how I did it. So if I come here, you see docker build -t Adedayo and the tag version. So if I build this, then I've made a mistake. Oh yes, I did specify the path of the Docker file, so it's inside this folder. So I'm going to say docker build -t TechWithAdeDayo, and I'm going to say simple login API, and I'm going to say version 3 because I already have two versions. I want to show you how I come to put this in Docker Hub. So I'm just going to say version 3, right? So I'm going to say this, And I'm going to say dot, which means find the Docker file in my root folder, in this place, my root folder. So it's going to build this. I'm going to say this, and it's building. In case your terminal is not by the side, it will be under. So I brought my own to this place because I prefer working this way. Great. So if I say docker ps, nothing is running. So, but if I say docker images, I should be able to see. And I have TechWithAdeDayo. This is version 3. I already have v1 that I pushed before. And this is version 3 right here, right? So let's run this version 3. I'm going to clear my screen. I'm going to say, and you can find it here. The command is right here. So if you come to TechWithAdeDayo, you'll find it docker run. This is it. And it should be TechWithAdeDayo simple login API version 3. That's what you run. This one, we don't have that image, so I will update this one. So just for you to see what I want to do, I'm just going to copy this and I'm going to paste it right here. And I'm going to change this to version 3 because that's our image. I'm going to say TechWithAdeDayo slash, right? And with this, I'm saying run this image, TechWithAdeDayo, and port forward 5000. So this is our local host port. This is ours, and this is our container port, right? So I'm saying port forward to 5000, so I'll be able to connect with the application outside. And this way as well, it's going to be able to connect with our local MongoDB, right? So if I ever stop this application, probably I do Control-C or anything, is going to remove the container and stop it from running. That's what this is for. So when I press enter, and it's this, and it's telling us that what? MongoDB connected from our Docker container, right? And we can test it using our Postman. I'm going to start my Postman. I'm going to open it. Right, and it's coming up. And it's coming. Let's wait. Great. So what I will do is let's register a new email. And I'm going to say training tech. I'm going to say 45 this time. And this is register. And I'm going to send this. And 201 task created. And I'm going to log in. So let's save this as login. I'm going to change this, rename this. I'm going to say login, right? And I'm going to paste it here. So this is 45, right? I want to change the password. I want to remove this 5 and 6 and see what it will return to us. And I'm going to send this. And it's telling me invalid credentials. So if I had 5 and 6 back and I send this, it returned the JWT token. That means our container has confirmed very well now that it is working perfectly. We are able to connect with our local from our Docker container, which is a very, very good thing. So with that being said, now we can go to Kubernetes. We can start from the beginning and understand its architecture, and then start with building different objects. But first, let's start. So, okay. But before we do that, let me just show you. So let me say Ctrl-C and show you how we can push this particular image to Docker Hub so that we can have the version 3 here. The version 3 in this place, right? So that's one more thing we want to do. So how do we do that? And it's very simple. Since we have the image, we know we have the image right here, Docker images. and this is it right here. The first thing we need to do is we have to say Docker login, and it's going to give us a direction of how to do this. I've already logged in, but for you, it's going to give you some form of activation and all that you are going to go to. Make sure you've created an account first, right? And after that, it's going to tell you login succeeded. And then you can say Docker push, which is very easy. It's specified inside this place, right? Docker push, repository image, and the tag. So I'm just going to say Docker push, and I'm going to say TechWithAdeDayo, and I'm going to say simple login API, and the version is v3, right? So when I do this, Docker push TechWithAdeDayo, and I do this, is pushing to our Docker hub, and it's from the Docker hub that will start pulling it inside our Kubernetes cluster. So let's wait a little bit. It's almost done. I'm pushing version 3. Pushed, waiting for this, and it has completed pushing. And if I go here and come to this place, if I refresh, then we have version 3 here, right? So that's how to push it. I'm going to delete this version 3 later on. So in case you don't see it, we are just going to use v1, v2. So with no further ado, let's just learn how to use Kubernetes. So I'm just going to go back and open my whiteboard so we can understand the architecture of Kubernetes. Okay, great. So I'll clean the board. And now we will deep dive into Kubernetes, right? So let's say Kubernetes. And one thing I want you to first know is that Kubernetes is the de facto standard when it comes to container orchestration. And we've looked into some of its benefits, like scaling, auto-healing, velocity, different types that we explained before. But now we are going to look at the architecture, right? But before we do that, let's first look at what is inside our Kubernetes cluster. And in our Kubernetes cluster, we have the control plane, which is also the master node. And also we have the worker nodes. This pretty much sum up what is inside our Kubernetes cluster. But to really get into the essence, we have to break this down and understand the architecture. And that's what we are going to do now. And let's do it this way. And let's say this is right here. I'll say this right here is the control plane. All right. right here the master node, right? And right here we have the worker nodes, right? And inside here we have something called the API server, and then we have something called the scheduler, and here we have something called the Kube control manager, and here we have something called the cloud control manager, right? And there's a bridge here which has something called the etcd, and right here we have kubelet, and right here we have container runtime, and right here we have pods, and right here we have kube proxy. So let's take this one after the other, right? So let's say this API server is like the entry for all commands in Kubernetes cluster, in the cluster. Wherever you are going to run, whatever command you are going to run for any object, we are going to see the object, or any command like we have something called kubectl, which we will install very soon. Whatever you are going to do, this is the entry. This is what you are going to be communicating with. And from here is where everything is going to go to other places, right? This is like the command center. Let's call it the command center. Right. Then we have the scheduler. And what scheduler does is simply it schedules pod into different worker nodes. According to resource constraints, which means if you want to deploy an application and the pod has maybe a CPU of 1 gig, a memory of 5 gig, this scheduler will check the node, the worker node. The worker node can be 1, they can be 2, they can be 3, 4, as much as you want. And the master node also can be 2, can be 3, right? It's always good to have many master nodes so you can have high availability, but that's a story for another time, right? So it's going to specify different pods into different nodes, and so look at a node and say, okay, fine, you have enough resources to take this pod according to whatever they've given it. It's going to do that. Then we have the kube control manager, and what this does is going to check node health. It's going to be checking and probing into the node and say, all right, is this node good? Can we, is it not failing, right? What's the CPU, what is left, and all that. And then we have the cloud control manager forgive my writing if it's not clear, but listen very well to my voice. So cloud control manager handles communication with cloud providers. We talked about abstraction of infra. This is part of it, how Kubernetes use it. So it knows how to create LB, creates volumes, volume claims and all that. So ingress and all that from the cloud. That's what this does. And if you are on-prem, you are not using cloud, this is not needed. Right? This is not needed. So in most cases, people tag it as optional because it's not needed if you are working on-prem, right? Then we have the etcd, which is like the bridge between the control plane and the worker node. And what this does is it stores the state of the cluster, right? In the form of key value pair. We'll look at it, right? So for instance, all your ConfigMaps, secrets, manifest, right? This is what stores it, etcd, right? They consider it the brain of the cluster. the brain, right? Then that's how that works. So this master node is very important. We are going to talk about it in depth later on, but as a beginner, this is just the things you need to know about the architecture of Kubernetes cluster. So let's continue. So this is kubelet, and it runs on all worker nodes in Kubernetes, right? And this is actually what checks this one as well. Check the node status. It checks if a container is running or not. If it's not running, it's going to just report to the API server and say, it's going to report to API server and say, look, a pod with a container just died. Please, can you tell the reconciliation loop or whoever is in charge of it to spin it back up? Or it can tell it to actually reschedule it to another node. That's what it does. So the worker node cannot work without a container runtime. So that's why you have something like Docker that we are going to use. You have Creo, you have Containerd. You have to have this container runtime because pods in Kubernetes, which is the smallest deployable unit in Kubernetes, runs on containers, right? Containers can contain one or two containers. We'll talk about that, right? And of course, this is the pods. And it's the smallest deployable unit in Kubernetes cluster, right? And it can contain one or more containers, right? There are rare cases where it has to have two containers, and we'll explain that, right? So that also will be in the worker node. Then we have kubeproxy, which handles the networking of pods in the worker nodes, right? So this pretty much sums the essence of Kubernetes. Essence of Kubernetes at its using a layman or a bird's eye view. This is the essence of Kubernetes, right? There are more things, there are more complexity to it, but to just understand it very quickly, this is how it works. So with that, let's just dive into pods, right? So pod is an object. So I'll clean this. Right, pod is an object in Kubernetes cluster. So these are things that we use to interact with Kubernetes cluster. We create objects in Kubernetes cluster. So I'll just say object, and the first object that comes to mind when you say is one, pod. And secondly, we'll say another object is what? Service. And thirdly, see another object is what? ReplicaSets. And fourth, we'll say deployment. And the fifth object that we are going to look into, ConfigMaps and secrets. And then the sixth one we are going to look into, and this is 5, and the sixth one is going to be persistent volume and persistent volume claim. So let's just run through this and then dive deeper into each and every one of them. So like we said, this is the smallest deployable unit in Kubernetes cluster. Is a wrapper for one or more containers, right? Ideally, you should only run one container in a pod, right? And pod has its own isolated environment, right? And one of the downside of pod is they have IPs that are ephemeral. What does ephemeral means? If a node dies, or a node fails, or a pod dies, their IP changes, which is not good. And we'll look at why this is a real problem in Kubernetes, and they used service to fix this problem, right? So we said it's a wrapper for one or more containers, and the reason why sometimes you have to have a pod running two containers is sometimes you may have a sidecar container. And what the sidecar container does is it pull logs, sometimes pull logs from inside this container and may onboard it on logging system like Prometheus, logging system like Grafana, like Elkstack, right? Prometheus for metrics. And yes, and you can even still pull metrics to Prometheus, right? And again, you can have sidecar containers like, okay, let me say Logger, then you can have something like a service mesh, like Istio, right? Istio, this service mesh, which monitors the network of the container. Then you can have another scenario of init container. Probably you need a config file that needs to be downloaded first. You need a config file that needs to be downloaded first before the pod will run. So this will be like init, then this will be the container. And everything has to be up at once, right? You cannot have a half-baked or half a pod that is half up. So all the containers running inside a pod has to be up before it will be up, right? If anything fails, if the init container fails to start, the container is going to fail. If the sidecar container fails to start, the pod is going to fail, so it's not going to come up. Then we have the second one, which is the service. And the service actually saves us from this ephemeral stuff by providing stable IP, and it is reliable, right? So we attach service to pods, and that way, anytime if the pod dies, the service still retains its own stable IP. We'll go into that, right? It's an object that is really, really, really one of the backbones of Kubernetes. And then we have the replica set. And what this handles is, first, auto-healing. And second, scaling. So what is this auto-healing? We've discussed it before. If a pod dies, a replica makes sure it comes back up. It keeps restarting it until it comes back up. So if you have two pods of the same application, and if a pod out of it dies or something happens or fails, this replica set makes sure that everything comes back to these two. So it makes sure inside whatever manifest file or whatever imperative configuration that you do, that your actual state that you specified matches the desired state, right? So that's auto-healing. It will always try to heal and make sure that you are in your desired state. Then scaling is very simple. You have a pod, one pod, and you want to scale that pod from 1 to 2. If you specify that in the replica set, was 1 before, you want it to 2, it will make sure it goes there. And if you want it to go back to 1, you can specify that back and it will go back to 1. That's the work of a replica set. Now, the fourth one that we are going to look into is deployment. And deployment is basically used to manage replica set. It's just one step ahead. And what it does is it can do everything replica set can do. But right, how it's more than replica set is it handles rolling update. It handles versioning. Right, can do something like blue-green deployment. ReplicaSets cannot do all of these things. So typically, you'll be using deployment mostly. You won't be using ReplicaSet object itself. You'll be using deployment to manage it. And when we come to that, you will come to understand what I mean by this, right? So just stick with me, follow me, you understand. So then the config maps. So anything that you don't want other users to see, you want to hide, or you don't want people to really see, you can put them in your config maps. Right? Anything about your application. Then secrets is just like the environment variables, like your JWT secret, your database strings, your AWS secrets and all that. Those are secrets, right? And you want to hide them. You can put them in your secrets, right? So let's say env files and the rest. Then we have the persistent volume and the persistent volume claim. So this is like storage. This object handles storage, backups in Kubernetes. So say for instance, your pod dies, and when it restarts, everything, your storage, everything is gone. Or you don't want it to be gone, right? You want your data to be saved. That's when you need persistent volume. And persistent volume claim is any resource that wants to use this volume, we write a claim to that volume. It may sound a little bit complex now, but when we get to writing the manifest files, you will come to really understand this, right? Just take this as a volume, as a backup. If something goes wrong with your pod or your deployment, you can always come to this volume, which can be in the cloud or which can be on your PC or your on-prem or your VM, whatever it is, and retrieve back those data. You can retrieve it back. So that's basically some of the objects that are very important that we are going to look at one after the other. So with that being said, let's go to our course, this thing. And now we are done with this. So I'm going to close it. I'm going to close this one. I'm going to close this one. I'm going to close this one. Close this one. And now we have our Kubernetes tutorial here. And you have your README. And in all, if you don't want to watch this video, of course, you can follow this tutorial. And it's self-explanatory. So you just start from 00 tutorial pod. And this comes from, this is start, the pod, simple pod and all of that. And inside there you have first README, which is the first one. And we're going to use Minikube, like I said. So we're going to install it locally. Everything we're going to do is going to be locally. And then these are the tutorials. And if you go inside them, README, this has README. This also has a README. You can follow all of this to create a service. And this is the application last. And this is where we are going to specify our pods, specify deployment, replica, ConfigMaps, and secrets, and persistent volumes. So you can go through all of this and do it by yourself. Else, you can just follow me in this video and see how we do this. So the first thing we need to do is we need to install kubectl. And so this is step-by-step Minikube installation. So first you need kubectl because that's the Swiss Army knife of Kubernetes. This is what we use to interact with our Kubernetes cluster. Whether on Minikube, whether you're in the cloud, on-prem, this is really very important. And then this is the step. If you are using Mac OS, you can, on your terminal, you can use brew, install kubectl. And in Windows, you can use Chocolate. But to make it easy, I can just say google.com. And I'll say install kubectl. I will just say on Windows. And if I go here, I'm just going to come here and it's going to tell me how to install it. And you can use call and then come back down, come back down, come back down. and I can use Chocolate, right? So this is Chocolate. I already have that installed, and I've installed kubectl. So if I come here and say git bash and open it, it's right here. I just like git bash. I prefer it. So I say kubectl. If I say this, it will bring it down. See different of its commands and options. And I'm going to clear my screen. So follow that. And if you are using Mac or Linux, it's here, right? Linux is here and Mac is here. That's quite simple. So afterwards, we are going to install Minikube. I already have Minikube installed as well. So you can follow this. You can use Chocolate, or you can, if you are using Mac, you can use Brew. Linux, you can call using this, right? Everything is online. So if I say google.com, I'll say install Minikube. On Windows, I'll say Minikube start. And once you come to this place, and it's going to tell you what you need: 2 CPUs, 2 gig free of free memory, 20 gig of free disk space, internet connection. You need a container runtime, just like I said. So we are going to be using Docker, right? And Minikube is just a single cluster that you can run locally, right? Because on a good day, Kubernetes clusters takes up lots of resources. So Kubernetes came up with an architecture that can make us, that allow us to learn whatever we want to do locally, right? So that's where this idea came from. So once you do that, Windows, if you want to choose Mac, Linux, right? And you can either go for .exe download, or you can use Chocolate. There's a place where you can use Chocolate. For me, I used Chocolate to download it, right? Just follow this. Just follow this, and you should be good, right? Make sure you have Docker running. So with that being said, I'm just going to go here, and I'm going to say Minikube start, right? Originally, if you want to start on your own, you can just say Minikube start driver equals Docker. This will start with your Docker runtime, container runtime, right? But I already did that before, so I'm just going to say Minikube start, and it's going to automatically pick it. So it's going to take a while to start. So let's just hold on.